Can you guys see the screen?
Just coming up.
Yep.
All right. So this is the basic idea. This is an event-based expiry long-short pair for shielding assets from smart contract risk. It should work for a variety of situations where you don't really know if the smart contract you're putting your tokens into is going to work out or not. It protects you from hacks, bugs, and potentially rug pulls, actually, depending on how you write the question. We'll kind of lay out an example scenario in the presentation. So an overview, like I said, they protect it from smart contract risk. More precisely, they limit the risk to UMA's long-short pair contracts, which have been audited by OpenZeppelin and battle tested in production. Basically, if these contracts aren't working, we've got a lot of other problems. So this is good because if you're using a new and experimental smart contract or something that's complicated or hard to reason about or changes frequently, you can go to this bedrock contract that UMA built, that we tested, OpenZeppelin tested. We're constantly launching things with this. So it's really useful. The only situation where you might have problems is if you need atomic access to the underlying asset, like if you needed to lend out like UMA itself instead of protected UMA, or you needed to do like a swap of the actual underlying asset, that kind of thing. But there's still a lot of situations where this is useful. Just to recap, so UMA's long-short pair token, it allows you to lock up a collateral token to mint a long token and a short token, which have different payouts. This is kind of a Swiss Army knife. We use this for KPI options, call options, success tokens, synthetics. And we actually have what we call the binary query identifier. We can ask a yes or no question that can also determine the payout of these kinds of things. So it's super flexible. We're just applying this pattern to create what we call a protected token and a recovery token. And the way that this works is that the protected token pays out 100% of the collateral if a target contract or set of contracts does not have a hack or bug that results in lost funds. This is the long token. The short token is the recovery token, and it has the opposite payout. So if you put the protected token into a contract that gets hacked or has a lockup bug or something like that, you can use the recovery token to get the underlying collateral from UMA's long-short pair contract. And again, this is just a pretty simple to reason about battle-tested contract, and it secured a lot of money already without having any issues. Yep, prevent this, basically anything. So here's an example. This is Simba protocol. It's a DeFi 3.0 protocol with some innovative Ponzi-nomics. They wrote the code in 2 hours and ran 0 tests, but they accept protected WETH instead of WETH. So basically, they get $100 million of protected WETH deposited in the first couple of minutes after launch, but then they lose the admin key. So they apologize. All the deposited tokens are locked forever. But since they use protected WETH, the depositors can actually recover the original WETH from the long-short pair contract with the recovery tokens, and they can live to ape another day. The devs can relaunch, try again. Everybody's fine, even though the smart contract that you put the assets into was terrible. Just kind of continuing with this, some more details on the process. Depositors mint WETH protected tokens and recovery tokens with the long-short pair contract, and they ape the protected tokens into Simba protocol and hold on to the recovery tokens. The binary query question tied to the LSP is something like, were funds lost in Simba protocol due to a hack bug or developer theft or error? And this can get kind of lawyerly, and you probably want to think about this a little bit, like what that exact question should be. And it might depend on what you're trying to insure against for a particular smart contract or protocol. So after the admin key is lost, that's just a really public, verifiable thing. The devs talk about it. So the depositors can go and redeem the recovery tokens for the underlying WETH, proposing an answer of yes to the question. So there's basically a challenge period when they're trying to redeem, where they make this proposal. They say like, hey, there was an issue that was insured by this, so we want to get the underlying with the recovery token. And if nobody challenges them, that answer of yes is accepted, and the WETH is returned 1-for-1 for the recovery tokens. If somebody challenges it, it could go to UMA's data verification mechanism. And because this is all public information, the voters could go and see like the devs posted, hey, we lost the admin key, sorry. And they'd be able to say like, yeah, this was an issue, that the recovery tokens should be able to get the underlying assets. So the alternate history is Simba protocol works out great. There's no lost funds. The protected tokens can be redeemed one for one at expiry for the underlying asset rather than the recovery tokens. So it's a little bit complicated redeeming beforehand. And so we'll get into that a bit. So before the expiration date, you can redeem the pair, the protected and the recovery token for the underlying asset. And that makes sense because one of them always has 100% of the value. And it's also true for any long short pair, but it's just really easy to think about in this case because one of them is worth the asset, the other one is worth nothing. So you can always redeem the pair. So in other words, if you can match them up, you can go and do that before expiry, which is good because you probably don't want to have a short dated expiry for a lot of these things. You might want to set the expiration date for a couple of years. So you want to have some way to redeem early. Something that would be useful, which is just an idea right now, would be an early redemption contract where you could offer recovery tokens for others to match with protected tokens before expiry. And it would only release those recovery tokens if there weren't any hacks, bugs, rug pulls, etc. Basically the same rules as like the underlying protected token. That would allow you to kind of sell smart contract insurance in a roundabout way. So if you go and mint protected WETH and recovery WETH, and then you put your recovery WETH up in this contract and say like, hey, like you can buy this for, some small amount of the underlying value. You're betting that you won't need that recovery WETH later, and you're handing that off to somebody else. So that's like one way to think about it, but it basically allows you to redeem early then. And there's also scenarios where a protocol that is running a rewards program, for instance, might offer a way to do this as well, where the protocol holds the recovery tokens and they just say, hey, you can redeem early at any time. We're not worried about that. Don't charge any fee. Just, you can't redeem early if there was an incident. So some more details about this. I'd like to actually take some time to write this out in code, but I think it's important hypothetical. Yeah, just a bunch of details in here. It lets you move fluidly between protected tokens and the underlying asset without using an AMM, which is something that I didn't mention earlier, but basically you don't need to like create a market for these tokens somewhere else. You can always redeem for the underlying before expiry if you can get the matching recovery token. And I think it should be fairly simple. It's just not something that we have yet. Everything else in the system we do already have. We have an early expiry LSP that's been audited. So you could set up all of this, but you wouldn't have this kind of automatic early redemption contract. You'd have to match it up in a kind of manual fashion for now. So here's a real world example. This actually came up before the compound rewards bug, but once that happened, we realized that this would be really useful for that. Basically, if the comp rewards were paid out in protected comp, there wouldn't be any risk of losing the underlying comp due to a bug in the distribution contract. So you have this smart contract upgrade. There was an issue with it that didn't get spotted. And there's all kinds of things that can go wrong with the smart contract, even if you're really careful, if it's something complicated. But this would protect against any potential incident, basically. You have this thin recourse wrapper of the protected token contract that would prevent losses. And Compound could either provide an early redemption contract or just manually, match it up with people for redeeming protected comp if there weren't any issues. So there is that one small extra step, but it's a pretty small price to pay compared to the potential losses, which can be huge in a smart contract system if something goes wrong. You also get a lot of flexibility in what you're protecting from. It's not like just one thing. It's kind of comprehensive for all kinds of issues that can happen with your tokens. So other applications. I think that there's a lot, but I'm curious if other people are thinking about applications for this kind of pattern in smart contract systems.
I'm curious if this could be useful in the NFT space for like, I don't know, I know there's like an issue in that space of like bots just coming in and minting all of the supply of NFT before the actual like people get a chance to get to it. I wonder if this could act as like a minting mechanism, sort of like insurance plan, if you will.
I'm not sure if it would help with minting, but it might be useful, like this pattern, not the LSP contract specifically, but this pattern for protecting against theft or other issues where you deposit an NFT in a contract and then that contract goes wrong. And it would require some additional work. You would need to have, I guess, a modified contract that accepts NFTs as collateral instead of ERC20 tokens. But I think the general pattern is solid. And I think that there are a lot of applications there because NFTs get stolen all the time, or you're hesitant to put a really expensive NFT into some complicated smart contract system, but you might be more willing to put it into a pretty simple protection like wrapper contract before putting it in there. And you wouldn't really lose much functionality in that case either, because NFTs aren't moving around as quickly or getting broken up as much as ERC20s.
John, I'm also curious about this point. Well, actually, first of all, hi, Brett. Welcome. I don't think we've had a group call yet, so nice to have you here.
Thanks.
But maybe I am very curious about this NFT as collateral concept and just how to wrap my head around it too. And I'm kind of curious if other people on the team have thoughts about if this is feasible or even kind of makes my head hurt, this idea of taking an NFT and making it be the collateral for one of these things.
I mean, the way I think about it is like, and maybe this is not the way you're thinking about it, John, but like, I kind of think of what you're really doing, the heart of this application, and abstracting it away from like the LSP, the heart of the application is like you're taking a token and you're actually splitting into two things. So you do the same thing with NFT. You go through the same process. You could imagine you sawing it in half, right? And each of us has like half the NFT. And if you put them together, they can kind of, you get back the original NFT. If you can't put them together, then one holder, one side of them could like request that the NFT be released to them because the other side has been compromised. I mean, that's kind of, so I think that same general pattern like works perfectly for NFTs, as long as you can design a smart contract that can perform that splitting function.
Yeah, I kind of think of that, what you were saying, Matt, is like Schrodinger's cat. Like you both have the NFT when the contract's live, but at some point one person will always have it. One of the things that I actually thought about while I was in Lisbon around this concept of a protected token was that idea of using it for under-collateralized loans, where at some point, if you take a loan out, you take the long side, and if you default on your loan, whatever collateral you have goes to zero. The only issue that I had with that kind of design that I was thinking about is that nothing stops me from like taking a loan. I know I'm never going to pay it back. I sell whatever money I got from the loan, and somebody else has to actually end up paying for or get the asset that I sold to them, and that gets a value of zero. And kind of one of the other team members, I can't remember which team they were kind of like walking through this process with me, and the idea was just to actually use a TradFi solution to have like a reputation-based system where your reputation is based on this loan, and if you don't pay it back, your reputation gets slashed, or you get a bad credit rating or whatever we can kind of like build into that. And then the other concept is that if you actually genuinely default past just your reputational level, then you can claim the loan person can claim back their original collateral that they put up for the loan, because they get the short side.
Yeah, I think that's interesting. I don't know if it would work within like the protected token pattern. It sounds like it might be kind of like a different thing though. So I think that this mainly just works as like a kind of a shield. It's just sort of like a wrapper contract. But I'm trying to think how you could apply the optimistic oracle to enforce these things, like asking the right questions to get recourse if somebody doesn't pay back their loan, or like their reputation gets slashed or something. Like I think it's a really interesting idea space there. And we're definitely just scratching the surface too. Like one thing that's cool about this is using the yes or no question kind of thing, which we also used in a modified version for a cross protocol. We ultimately, set up a unique identifier for that for convenience, but the core idea is you can ask any yes or no question to the Oracle, or really any question that has a verifiable answer that anybody in the public could go and verify and get that answer. So yeah, I'd love to see some more of that, like more thinking around that.
Can I ask if you need to have one type of protected token per smart contract? So say there was Simba protocol and Mustafa protocol, and they both accepted protected tokens. Would they be able to accept the same one, or would you have to have different protected tokens for each smart contract?
I would think that you'd probably have different protected tokens for each one, unless you wanted to tether all of the risks together. Like if Simba and Mustafa are really like closely tied together, and you just say this entire ecosystem is bad now because one of them had an issue. Because if you had like, let's say you have like 3 different somewhat related protocols, but they accept tokens in different contracts, you might have a situation where, one of them can go down and the other 2 are fine. But if that one goes down, the answer to the protected token question is like, yes, the recovery token can now recover their funds, which means anybody using the protected token in the other contracts now, those protected tokens have become, worthless. And I could see situations where you might want to do that, I guess. If the person who deposited the protected tokens in those other contracts held on to their recovery tokens, they can still get their assets, but they might not be happy about it because they might be doing other things in those protocols. They might be like trading, they might be lending it out, but doing stuff that they want to actually cash out in the protected tokens. So they might be annoyed by that. I think it's probably simplest to break it up. And it gets more complicated once you try to link these things together. You have to really want to tie those risks together. And I'm thinking some more about the NFT thing. One nice thing about that is this is like an all or nothing kind of use case of the LSP. So you don't have to worry about complicated payout functions that only really work for fractionalized tokens or something. It's one way or the other. And the Schrodinger's cat thing is kind of cool because you could do like a Schrodinger's crypto kitty like example things. There's like a nice pun based launch idea if there was like an NFT collateral that you could accept.
I had a question just around like the dynamics of the protected token, not so much an application, but one thing that becomes apparent to me that if a team has this concept of protection that they could fail and it'd be okay, that it introduces a level of moral hazard where they don't actually have to do things by the book. They could maybe take some shortcuts and just not do things 100% because they know that there is some sort of fallback. We've seen this happen before in like multiple spaces, but do you think the idea of teams having this layer of protection makes them like gives the consumers the confidence that they want to be able to like trust this protocol? Or do you think it introduces a level of like protocols being able to play on the wilder side of things?
I think it definitely introduces like more opportunities to play on the wild side of things, but I think that's a benefit of it because I think that protocols and projects are doing this already. Like the cost of doing it by the book is pretty large. Like if you want to get a top tier auditor and go through that whole process, there's a big time and monetary cost there, and you lose a lot of like speed. So if you're able to do it in a way where everybody agrees, like, okay, this is risky, but it's a limited risk. Like you can jump into this protocol, you can play around in the smart contract with protected tokens. If it turns out there was an issue, you might not get out the same amount that you expected, like if you made money within the smart contract, for instance, but it's denominated in the protected tokens, which become worthless and you only have the recovery tokens, you at least get out the amount that you put in. And then, other people could also like buy your recovery tokens, and you're kind of selling them smart contract insurance, and you have this natural way to insure that risk then. But I think it lets people iterate quickly. And I think that's actually one of the big advantages and maybe one of the big appeals. Like you could imagine having test contracts where you're testing in prod with real assets. And if something goes wrong, nobody's actually losing the money that they put in there outside of gas fees, I guess. So I think that's actually really great. And it lets you discover things faster and experiment faster.
So maybe we've already talked about this, but my big, I think the big question for me is how does this work in a composable DeFi world? So this works really well for things because you have a staking contract and the author of the contract just wants to pay you tokens for staking your tokens. And they can say, oh, you put 100 UMA in this contract. That's great. We're going to pay you some rewards on that 100 UMA. But the second you want to do something more let's imagine some sort of vault, like a Badger vault that goes and does something with your tokens, or that wants, or an LP, like LP tokens or something like that, where you're offering liquidity or something. It becomes a little bit more difficult, I think, to because you don't have access to the underlying tokens. So you need people to take this Badger Vault protected token thing instead of taking the actual the actual real collateral, which means that effectively the downstream, the places where that protocol might deposit those tokens are exposed. They are actually exposed to Badger's vault failing, because if Badger's vault fails, then the underlying collateral backing this whole thing that Badger is moving around is worthless. So yeah, how are you thinking about composability? Basically, that's my question.
Yeah, no, I think that's a really good point. I mean, you could sort of start by thinking about this as a closed ecosystem. You put these protected tokens into some kind of ecosystem, and you have protection within that ecosystem, and then you intend to pull out and go and do something else with them and turn the protected tokens into the underlying assets to go and do stuff somewhere else. I could see situations where you have a lot of assets locked up in some kind of protected token system, and people want to accept those protected tokens for trading or as collateral or whatever. If the value is there, then people might take that risk. But I think you're absolutely right. Then they accept the smart contract risk, and they might want to hedge by getting some of the recovery tokens as well. So it kind of has mechanisms to develop its own insurance market, because you can always hedge your risk by getting recovery tokens, which is complicated and different, but I think you could do that.
Right. I mean, I agree with you. I think that's very, very elegant. And I do think this is still a primitive that would be very useful, because you could imagine that the downstream protocols just acquire a bunch of the recovery tokens and say, well, we're not 100% insured, but we're we own, 1,000, Badger Vault tokens or whatever. So that means that but if we buy, 500 of the recovery tokens, that means we're half hedged. So worst case, you'll be paid out 50% if we lose, if Badger gets hacked.
Yeah.
So that's
the recovery tokens should be cheaper than the protected tokens, unless people are this contract is absolute trash and this is 100% going to get hacked, right, or the developer is going to steal all the money.
In some ways, it's a really natural way to build what next, to tokenize the kind of Nexus Mutual thing, where the insurance on something.
Yeah. There's also situations where the main risk that you see is an admin key or something, and you can insure against the dev stealing all of the money with this. If they want to steal the money, they have to wait a couple hours for somebody to challenge them on the money they stole, and so then they just can't. There's no economic incentive to even try. And so if you feel good about everything except an admin key, this gives you protection from the admin, because they can't just cash out.
Yeah.
From an execution standpoint, it seems like the lowest hanging fruit would be to create a application or environment with the problem being the OZ model is unsustainable, and teams need better ways to test and get battle test their contracts. You could create a whole product just around that, and I think it would be received really well. And maybe even OZ would get in on it or something.
Yeah, no, I mean, I think it's interesting. I'd be curious if people do pick up on this because, you can test on test nets, but you don't get a sense of the underlying economics. Like if you want to test how are the fees going or something, you need some kind of economic thing happening. And this lets you do that without exposing yourself to a bunch of smart contract risk. So early stage teams or smaller teams or less funded teams, I think this is really, really useful. And they can probably get a better picture too. I think you could attract a lot more capital into your nascent experimental smart contract because people know that their losses are limited to gas fees, basically.
And it's the highest of risk, but highest reward because that's as soon as you can get in on it,
Yeah, exactly. If it doesn't get hacked and you're earning a bunch of protected tokens or something, then
yeah,
you have a nice way to reward people for that while limiting their risk a lot. So I don't know, the rewards might go lower then in the future because the risks are more limited, which I think is fine.
Has there been any?
You think if people are going for these extremely risky protocols, do you think they care enough?
I do think so, yeah. I mean, I think you could still get rewards that are adequate. This just removes so much risk. I think you could put larger amounts in or survive in the game longer, and just experiment more. Because there's a bunch of things that limit your ability to experiment in smart contract networks, and gas fees are one, but another is just the consequences of screwing up are so huge. So I think as a user and as a developer, this is way more fun to experiment with.
You're also exposed to UMA systemic risk as well. So it's not
Yeah.
you're getting rid of all risk. You're kind of exchanging one set of risks for another.
Yeah, absolutely.
Is there any exploit control with regards to the formation of the yes/no question? Or is there any way to prevent somebody from making protected with and saying, do I just not like the way that this worked out? So they put that in and maybe trick people into thinking it's some protocol specific, like ALETH or something, but P with. And so people think it's just a wrapped form of ETH, and then they call it all back because they didn't like the way that it worked out or something like that.
Yeah, no, I think that's a good point. And if it becomes really popular, there would need to be a good way to publicize what the specific rules are for a particular protected token, because you can write that yes or no question in a bunch of different ways. I do feel the UMA community would be really loud about somebody who seems to be up to some schemes. But that's not a good systemic answer. I'm not sure if there is a good broad enough answer to always protect you, because you can ask the Oracle any question and you can design your the risks that you're protected against any way that you want. So you might design something where it's you're protected from smart contract bugs or hacks, but the developer is allowed to steal the money technically or something. And you are still kind of exposed if you're up to shenanigans, because if things go to a dispute, the voters are able to read into the intent and the expectation of the question. And so that's why I think it should be sort of a lawyerly exercise to make sure the question is really clear of what the answer should be, and that everybody's on the same page on that answer, so that you can't trickily write the question that you're allowed to steal the money or something.
Interesting. Very cool. Thanks.
Yeah, we're kind of embedding law into the code now. It's a little pocket of a legal agreement in this ancillary data question.
I mean, I think you get into trouble with this when like, I think if somebody's obviously scamming, it's like pretty easy to make the decision. I think it's problematic when like a bunch of when like 50% of the people use the token correctly and then 50% of the people like didn't understand it and use it in the wrong way and like lost a lot of money because of it. And then you end up in this situation where you don't really know, like intent is kind of important here. And so like what you don't really know whether, yeah, I don't know. It's just, you get what I'm saying? It's like kind of hard to, it's hard to figure out how to do the payouts so that like the people who were confused and used the token the wrong way or were potentially scammed or something are paid out, but like the people who use it correctly kind of are also kept safe.
Yeah, for sure. And I think that we could write some example language. So every time that I've talked about this, I didn't have any really precise language around what the question should be, but we might want to have just like a default question, like a boilerplate protection from smart contract risk sort of thing with no, caveats, and then set some precedent around that of what you should expect the Oracle to respond with. But it does become like a law thing. I mean, you've got like precedent and case law and stuff. Like language is tricky, and we can try to make it as precise as we can. It can never be as precise as code, but that's kind of the strength of it too. Like it allows you to have that human mediated recourse and cover a broad range of things in a really short string of language that would be unreasonably long to actually encode. And you'd never be able to catch it anyway. And that code would also probably be wrong if there's bugs elsewhere in the code. But yeah, I think probably the starting point is just getting a good boilerplate thing, just like smart contract risk in general.
Yeah. So
Do we think we should issue a bounty for this?
For the like the early redemption thing, or for the question?
I was thinking more of like the building out like the application, the first like app around like people being able to just like a battleground like environment for people to play in and issue these tokens.
Oh, that's kind of interesting. I feel like we implicitly sort of have that. Like if with the KPI options with the superhumans, like if somebody were to use protected tokens for some new protocol that they're building, then I think that would count as an integration. So the way that that's sort of set up, you have an incentive to suggest that where appropriate. Yeah, I'm not sure like what an interface would look like or anything, but I think it's worthwhile to talk to the superhumans about that and kind of explain the concept and see if they know any teams that this would be useful for that specific case. For the early redemption thing, I think that we should build that out, and that might be an internal thing, just because that's really useful. Because there's a lot of scenarios where you wouldn't necessarily need that, and like a reward scenario, for instance, if it was like the compound rewards type situation, you could just reach out to Compound and they just like send you the recovery token along with the protected token because they've been watching this and they were like, no issues. They'll just, do that once a week or something, whatever it is. But when you have a lot of diffuse people interacting with some contract and you want them to match up independently, you would want to have an early redemption contract available.
So take, for example, the compound thing. Would this happen, would the protection happen at protocol level? So people would still send their compound to Compound or their tokens to Compound, yeah? And then Compound would put them into a protected token contract.
So in that scenario, it was just like the Compound treasury had a bunch of comp they were giving out as rewards. So instead of giving out the comp, they would wrap it as protected comp and give out protected comp. Because they put it into this sort of rewards contract that distributed it, and that's the contract that had the bug. And they had all kinds of mechanisms to like, deal with it and kind of have like delayed upgrades. The admin can't do something, all these written in code protections, but it would have been simpler and more effective if this pattern existed, that they could just do protected comp, because if anything went wrong, they would notice and just say like, hey, the protected comp cannot be redeemed for the regular comp now. We're going to propose that there was a bug.
Sorry, I wasn't quite familiar with that hack. I was thinking more in terms of how Compound usually works. So say you put WBTC into Compound. If they wanted to, if Compound wanted to use a protected token, would people just send them the WBTC and then they would protect it within their treasury?
So for that, like if you had like not Compound specifically, but like a lending protocol and you wanted to test it out, you would wrap it as protected WBTC before depositing it as a user, because then you're protected from the protocol. I guess if the protocol had like a bunch of funds, and this maybe goes to the composability thing, like let's say you have a vault kind of situation and you want to earn interest on it in some experimental new protocol that accepts protected tokens, you could wrap the assets that are in your vault, hold on to the recovery tokens, deposit the protected tokens, and go earn that yield in this new experimental thing. So maybe that actually helps composability now that I think about it. If you have like all of these wild new things launching left and right, and they use protected tokens, so vaults can put however much capital they want into it safely, and they still have the underlying asset. So it's like one step removed. It's like one protocol wrapping it instead of wrapping it before putting it into that protocol.
John, do you want to run through like how Hats use or is intending to use this idea?
Yeah. So we're in conversations with a protocol called Hats, which is basically kind of like a bug bounty sort of thing. So you put some of your tokens in a vault, and then white hat hackers that discover a vulnerability in your protocol can report that vulnerability, and they get some amount of the rewards from that vault. And so part of the thinking from this just came from that conversation, because it's like, how do you judge the risk of putting money into the vault? Like, what if there's an issue with the vault? Like, it looks fine, but like, how do you actually gauge that smart contract risk? It would be great if we just didn't need to think about it at all. So what we're talking about doing right now is putting protected UMA into the vault. So then if there's any issues with the Hats vault, the UMA would still be, safe. And so then that kind of like saves time on needing to like thoroughly understand everything about this contract that you're putting funds into. So that's really cool. And so then we could feel safer putting funds into that vault and double up on our safety, because the whole point of that protocol is to incentivize reports of any issues within UMA's protocol. And I think,
John, what's like the next step you want to go? Like, I mean, Tom had some other ideas about like building this battleground or whatever, but I mean, in terms of us being able to do this, what's holding us back now?
Nothing really. I think like we've got the audit report that we're going to share publicly, so that'll have the early expiry LSP. So that's ready. There's a lot of cases where you would want to have that early redemption contract that doesn't exist yet. So building that and auditing it and releasing it. But I think that we can move ahead with some integrations where.
Sorry, John, is the early redemption contract any different than the early expiry contract or the event-based expiry contract?
The early redemption.
I missed this. I'm sorry for being dumb.
Oh, sorry. Let me.
No, it's more like I think I just equated them as the same concept as in my head.
I'll skip back to it because it has kind of like a useful wall of text sort of thing going on. So basically the idea is before expiry, you want to have a way to redeem for the underlying asset. And this would allow you to match up the protected token with the recovery token. So, nothing's been hacked, everything's fine. You have the protected tokens. You can't turn the protected token into the underlying asset unless you can match it with the recovery token. And if you're in some kind of protocol where you're like earning more than what you put in, which, you know, is the case, I think generally, like that's the idea, you need to go get some more recovery tokens. You don't just have the recovery tokens that you had originally. So you could go to this contract and you could get those recovery tokens either for a fee or like zero fee if it's like, you know, something like the compound rewards scenario. And that would just let you do it without it being a manual process to match them up. And it also lets you set like a price essentially for smart contract insurance too. Like if you're earning a bunch of money, but it's all denominated in protected tokens, you can be getting those recovery tokens through this market and then eventually cashing out this way too.
Could we use the optimistic rewarder for this?
Well, I guess I'm still, before we go there, like, why can't we use the event-based expiry stuff more concretely? Like, maybe it's not exact. Yeah.
So, because the event-based expiry doesn't help you if the event doesn't happen. So if there's no hack or bug, you can't redeem. So event-based expiry works if there's a hack or bug, but not for like going and getting the underlying asset if there's no hack or bug and the expiry hasn't happened yet.
Well, but theoretically, right, somebody could just have a pool that lets you trade the unprotected token for the protected token, like one for one, you know, particularly the project that would kind of get there.
You could, but the impermanent loss would be like, it would be an insane scenario because one of them is worth nothing if like something goes wrong. So you'd have to be a really confident LP, but you could do that.
Well, I'm even saying like the protocol could do that too. You know, I guess I'm just, because I guess in this other version, I'm missing something too in my head where you like, I guess I'm conceptually, how do you because this looks like the event-based expiry thing. I guess I don't quite understand how this other feature of like this early redemption works on a case-by-case basis. Is it just simply that because if I don't have my short token, how do I do that?
Yeah, this is like basically where other people can put the short token into this early redemption contract and offer them for sale to other people to match up. Because the other option, if you had like a pool, you have the impermanent loss risk if anything ever happens. You also need to have twice as much liquidity for the system to work then. Like if you have $1 billion worth of protected tokens, you're going to need like a lot of liquidity in that pool and you know, the underlying collateral matched up against the protected tokens. And it becomes, I think, more complicated than this because if you just get the recovery tokens, which always exist one for one as a match for the protected tokens, you can redeem for the underlying collateral. So I feel like this simplifies the system and probably makes the fee structure more straightforward as well.
And in that case, couldn't you do the same thing by just having, because like the recovery token is usually going to be held, I think in most use cases by like the protocol or something like that, right?
I think the recovery token would be held by like the users. And well, it depends on the case, I guess. Like the compound rewards example, the protocol is the user that's protecting themselves from themselves. But if you're like aping into some experimental protocol, then you just hold on to, you know, your recovery token.
Yeah.
But you have the option, if you're confident, then you can just sell your recovery token and it's kind of like selling insurance to somebody else.
I think, because I think I could imagine design is just simple, like you just have I'm just not sure. I guess I'd push you on like, I think you can accomplish this by using our same event-based expiry contract where you just have the recovery tokens available for people to buy and redeem their protected token in some other mechanism through some other contract or something like that.
Yeah. I mean, this is kind of what I'm proposing here.
So it's not exactly like new logic. It's not like changing the LSP to add new logic to it.
No, yeah.
Okay.
Yeah, it's just a
where
place to go to like buy them. And I think the extra logic that I wrapped around this is just to keep people from buying them if there is an incident. So like once there's an incident, you wouldn't go to this contract to go buy recovery tokens anymore, because that would like, screw up the price model or something.
Okay.
At that point, all sales are closed. So that's basically what this is.
Okay. Sorry, that's clarifying for me. So yeah. So okay, I got it. I think there's still then use cases that we don't need this for, like actually potentially for the fractional art NFT thing or other stuff like that. And so
Yeah.
I talked for too long now, but I think that this is I think there's use cases here that we should like push on ASAP, because why not?
Yeah, I agree. And like the Hats Finance one, for instance, is one where we don't really need this. Because the way that flow works is somebody reports an issue with UMA, our committee reviews it, and we say like, yes, this is a valid issue, and we set the size of the reward, and we release the reward from the vault. As part of that flow, we could just also send them the recovery tokens so they can redeem for the underlying. And that's fine, because they're only dealing with one entity, and there's some manual steps involved anyway. So yeah, there's plenty of situations like that. I think the compound rewards one is like another example, and there's tons of other situations like that.
I think it's very cool, John.
But yeah, I mean, yeah, we can roll with that right away. So I'm excited for this, and I'll think some more about like the simplest way to write this early redemption contract, which would really open it up for a range of other cases too.
Great idea, John. This is awesome.
Anybody else have any thoughts on this one before we wrap up? All right, everybody. Thank you for joining. Pumped about this one.
Thanks, John.
Thanks, John.
Thanks,
Thanks.
John.
Bye.